Welcome. So we're going to be graphing quadratic functions in standard form in this podcast. And so we're going to go through all of our steps. We're going to find our features. And our important features are the direction of the parabola, the axis of symmetry, the vertex, the y-intercept, and the x-intercepts. In addition, in this podcast, we're going to learn how to use the steps for completing the square to rewrite an equation from standard form to vertex form. First of all, though, let's determine the direction of our graph. Right? So to determine the direction of your graph, you're going to look at your a value. And in standard form, a is the coefficient in front of x squared. Right? So, and that's for standard. And of course, standard is when we have the x squared, and then we have the x, and then we have a constant. Now, sometimes one of those, not the x squared, but maybe the x term or the constant is missing. That's okay. It's still standard form. But it looks very different than our other two forms, vertex and intercept form. Right, so if a is greater than 0, in other words, it's positive, then your graph will face this direction, and it's called concave up. Okay. If a is less than 0, it's negative, your graph is going to face this direction, and it is concave down. Right, so let's identify our a here. For this equation, a is equal to -1. Whoops, I don't know how that happened. My board just kind of moved funny. I must have hit something on the sides. Oh, I think I probably hit the extended page with my arm. Well, sorry, I'm going to have to do this. Otherwise, my writing is kind of small, so this will adjust my page back to what it was. Right, so a is -1. So since a is less than 0, our graph is concave down. That's all there is to that one. Now let's find the axis of symmetry. Divides our parabola into two symmetric parts, right, in half. And it divides in half at the vertex. So when we find our axis of symmetry, we get two things. We get not only that line that divides our parabola, we also get the x-coordinate of the vertex. When your equation is in standard form, you can use this handy-dandy formula. So this is just if it's in standard form. We have other ways for vertex and intercept. So we already know what a is. That's -1. And b is the coefficient in front of x. That's -8. Right, so our axis of symmetry is going to be -8 divided by 2 times -1. So there's two negatives, those will cancel. So that's going to be a +8. And we're going to divide that by -2. Oh, I'm going to put a negative sign there. So that's going to be -4. So our axis of symmetry is the line x equals -4. And as a bonus, it is the x-coordinate of our vertex, and we call that, because it's a special x-coordinate, we don't just call it x, we call it h. Right? So h is used to represent vertex. Not only in parabolas, but also in other equations like absolute value that have a vertex. All right, so now we need to find the y-coordinate of the vertex. We already know the x-coordinate. All right, so let's actually write this down. All right, so the x-coordinate of the vertex, or the h, is the same as the axis of symmetry. So So that gives us both, right? Because it's a vertical line, and so x equals a constant, that tells us the x-coordinate of our vertical line, where it crosses the x-axis. So that's the x-coordinate of our vertex. To find the y-coordinate, the k, you have two choices. One is to just substitute the x-coordinate, substitute h, into the equation. The other choice is to use that formula. K equals the opposite, b squared minus 4ac, all divided by, 4a. I think my hand is working faster than my brain. Divided by 4a. All right, so that's how you find the x and y coordinate of the vertex. When would I use that k formula? If I had a number from the x coordinate of my vertex that maybe I didn't want to plug back in. So maybe it was 7/65, and I didn't really feel like plugging that back in and squaring it and combining it with other numbers. Maybe I say, I'm just going to use that formula. But if my x coordinate is just a -4, well, that's pretty easy just to plug in. That's what we're going to do. So we're going to have a -4 squared. That negative is not squared. You only squared what's directly in front of the square. In this case, it's the x. So everything that we plug in for x, that gets squared, but not that negative sign. Then minus 8 times -4 plus 9. And so we have negative. So -4 squared is a positive 16, so it'd be a -16 now. And then -8 times -4, that's a positive 32 plus 9. Right, so just about done. -16 plus 32, that's like 32 minus 16, so that's 16. And 16 plus 9 is 25. And so now we have our vertex, -4, 25. And so we're going to be graphing this. We're going to have to do something about that, like change our scale. Our scale is not going to be able to be 1 if we want to graph the point -4, 25. And you always have to graph the vertex. It's an extremely important point for the problem. Now let's find the y-intercept. Each of our formats has something that's easy to find about it. And for standard form, it's the y-intercept. If we were to remember, the value, our y-intercept is always the value of y when x is 0. And if we were to plug in 0 for our x's, everything except for that constant term is going to be 0. And the only thing that's going to be left is the 9. So you don't actually have to do any work to find the y-intercept when it's in standard form. Whatever the value of c is, that will be your y-intercept. And that's just for standard form. We'll have to do a little work for the other forms. So before we find the x-intercepts, let's look at how to find the vertex by rewriting it from standard form to vertex form. So you can find the vertex by rewriting using completing the square and changing to vertex form. So this is very much the steps for completing the square, except actually two key differences. One, you can't get rid of any terms. So we're not going to divide by each side by a number and get rid of it. And also, we're not solving. So we're not trying to isolate x. We're just using the steps to rewrite the equation. And once we have it rewritten, right, then we're going to isolate not x, but actually f of x. You have this in your notes, right, and mine is color-coded. And depending on when you see this video, yours may be color-coded too, because I accidentally printed a whole bunch of them in color. So you'll have the exact same color. Right, but a lot of these are going to be the exact same steps as completing the square. So, but we're not going to replace f of x with 0 because we're not solving. So we're just going to leave it as f of x. The The first thing we're going to do is move the constant term. Now normally if we're solving, we divide everybody by a, and that's the end of a. But since we need to keep a, we're not going to do that as our first step, we're going to do it as our second step. Instead, we're going to move the 9. We're going to subtract 9 from both sides, right, to move it to the other side. Because we're going to work with the x's, right, to rewrite this using completing the square. So we have f of x minus 9 equals negative x squared minus 8x. And I'm taking extra care to make sure I do not make any copying errors, because I had already, oops, no, I knocked over the eraser. I had already done this video. But I had a copying error, and I just couldn't find it. And so I stopped the video, and as soon as I did that, I'm like, oh my gosh, I wrote it positive instead of negative. So always make sure, the lesson of this one is always make sure you write down the terms just the way they are. You don't accidentally write down the term incorrectly by changing its sign. Anyway, let's go back to our problem here. So we've moved the constant term over. Now we're going to factor the a out. Right? We can't get rid of it, because if we do, that would change our graph. Right? If we change a, we change the problem. Right? So we are, on this side, just going to factor it out, and we're going to leave it there. That's why we moved the 9 over, because we don't want to deal with that. We just want to deal with the x's. All right, so now if we divide x squared by negative 1, that's going to be a positive x squared. Negative 8x divided by negative 1 is a positive 8x. All right, so now we're going to make the right side a perfect square. And just the stuff inside the parentheses. We're going to make that a perfect square. And to do that, of course, we have to add in the very, very special number. And that very, very special number is buzz, 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 divided by 2 squared. So b divided by 2 squared. We have to add that to both sides. You'll never forget b divided by 2 squared, because I keep buzzing in your ear. So we have f of x minus 9. Since I need to figure out what b divided by 2 squared is, what I'm adding here, I'm going to leave a space. It's always a good idea when you're trying to figure something out. Just leave a little space for it. So we have f of x minus 9 equals negative, and then we're rewriting this stuff in the parentheses, x squared plus 8x. So our b is 8, so we're going to add 8 divided by 2 squared. Get the other parentheses in there, to both sides. There we go. Oops, let me move the equals. There we go. Kind of crowded over there. All right, so now I added something to one side, I need to add it to the other. But did I really add 8 divided by 2 squared? So we need to think about it. What happens if I distribute that negative back? Well, the sign of that term is going to change. It won't be positive anymore, it's going to be negative. So I really didn't add b divided by 2 squared. I added in a negative b divided by 2 squared. So very important, if your a, just need more space here, if your a is not 1, don't forget, whatever you add to the other side, make sure it's a times what you added. Now it matches. So we really added negative 8 divided by 2 squared to the right-hand side. I need to add negative 8 divided by 2 squared to the left-hand side. Now let's simplify. That was the end of that step. So we have f of x minus 9. 8 divided by 2 is 4, and 4 squared is 16. So we have minus 16 equals negative x squared plus 8x. This one is a positive 16. But we know it's really not if we were to distribute that negative back. Let's combine our like terms. So we have f of x minus 25 equals negative x squared plus 8x plus 16. So by the way, as we're doing this, I want you to think about what the vertex was on the last page and see if you can see the terms from the vertex just popping out somewhere. Our next step, which is going to be in purple, is to factor the trinomial. Right, so we're not doing anything with this side over here. On the right-hand side, we're going to factor that. Remember the pattern. It's going to be x, and then whatever the sign of b is, in this case it's a plus, and it's always half of b. So it's going to be a 4. And we know there would be 2 of them, right? It would be an x plus 4 times an x plus 4. So if we factor x squared plus 8x plus 16, it would be x plus 4 times x plus 4. And what's it called if you multiply something by itself? It's that thing squared. So you can write, if it helps you, x plus 4 times x plus 4. Or you could just write x plus 4 squared. If you're not sure, you can always check yourself by multiplying x plus 4 times x plus 4. Right? I'll just kind of show you really quickly. All right, if you were to do that, right, you'd have to multiply. So if I do it as distribution, I'd have to multiply the x times x plus 4 and the 4 times x plus 4. And we get x squared plus 4x plus 4x plus 16. All I did was distribute. And now if I add those, I get x squared plus 8x plus 16. Exactly what we have in the parentheses. All right? So just in case you were doubting it in any way, but you don't need to write that down. I'm not even keeping it. All right, we're almost done. We need to isolate the f of x because we're rewriting this. We're not solving. So it's the y, or f of x, that needs to be isolated. I'm sorry, I'm going to have to write with red because well, let's see if I can get to. So when I'm recording, sometimes things are hidden by a recording box. There you go. Because I care, orange. And let's get rid of, I think you can now see the line color, and I don't know how to get rid of it. All right. Go away. Well, now nothing wants to go away. All right, so we'll just deal with the little box there. Will it go away now? Oh, no, if I put it down, it won't. All right, so ignore the little box, and I'll write the last step, and then the little box will go away. All right, so our last step is simply to isolate the f of x by adding 25 to both sides. So f of x equals negative x plus 4 all squared plus 25. Now the box goes away. All right, and now we have our equation in standard form. So I said, see if you can figure out, see if you can see the terms, right, from the vertex just popping up. And now they've all popped up, haven't they? So our vertex remember the format, it's x minus h squared plus k. That's our form, then we have an a here. That's our format for vertex form. And so if we have a positive 4, I wanted to move that away. I don't have much space. If we have a positive 4, that means what we really have is minus a negative, because that negative is already there. It's the difference between x, any x value in the vertex. Right? So here's our format for vertex form. Our vertex then is going to be negative 4, and then the number we add to the whole thing is the y coordinate. So negative 425. So the vertex is the easy thing to find when it's in vertex form. We just have to identify it. So negative 425 is our vertex, and that's exactly what we got on the other page, right? Negative 425. Now, why might you want to rewrite this into vertex form? And of course, I could do it a lot faster. See, negative 425. If I wasn't talking the whole time, right? The reason you might want to rewrite it into vertex form is you get the vertex and it's half solved for you. So let's take a look at another equation that has nothing to do with this one and just look at how to solve if your equation's in vertex form. Right? And then after we solve our equation in standard form, we'll go back and solve it in vertex form so you can see. Right? So let's just take a look at this equation that's in your notes that has absolutely nothing to do with that other equation. Oh, I'm sorry, it is that equation. Sorry. So now let's take this equation that is exactly the same as the equation we were just working with. That's what I get for looking a little too quickly. So exactly the same as the equation we just had up there. So here's our equation in vertex form. Right? And so now we're going to look at how to solve when it's in vertex form. Right? And then maybe we'll also solve it another way, right? So that we can get two practices in. All right, so if your equation's in vertex form, here are your steps on the right-hand side. First of all, you just substitute 0 for f of x. So you have 0 equals negative x plus 4, all squared plus 25. And you isolate the something squared. You don't expand it. You don't do anything to it. Just isolate the something squared. It's half solved for you. All right, so we're going to subtract 25 from both sides. So we have negative 25 equals negative x plus 4 squared. Now we have to divide by a, because we have to isolate the something squared, and the something squared is not isolated yet. Now we have 25 equals x plus 4 squared. Right, and so now we can take a square root. Don't forget the plus or minus by the 25, because there are two numbers when you square them that you get 25. So we need to have those two numbers. Here, in this case, the square is just going to undo, the square root is just going to undo the squaring. Right, so on the left-hand side, square root of 25, we have plus or minus 5. On the right-hand side, we're going to have now x plus 4. And so now we want to solve for x by subtracting 4 from both sides. So that's a negative 4, put that first, and plus or minus 5 equals x. Don't leave your answer like that, right? Because we can simplify that. Those are just numbers, we can combine them. So we have x equals negative 4 plus 5, and x equals negative 4 minus 5. So negative 4 plus 5, that's going to be 1. So 1 is a solution. That means 1, 0 is an x-intercept. And negative 4 minus 5, that's just going to be negative 9. And so if negative 9 is a solution, that means that negative 9, 0 is an x-intercept. Oops. And if I hit extend the page, my 0 ends up in the wrong spot. There we go. All right, so on a problem like this, where we have rational solutions, that means that this was factorable. So I could have just factored my equation. So when would I want to rewrite it into, here we go, vertex form, and then solve, is when I don't have something factorable. All right, so if you have an equation that's not factorable, you're going to get two things for 1. So we would skip, so back here, we could skip the whole find the vertex thing. All right, and so you could just rewrite it into vertex form. You got the vertex, and then just plug in a 0 for the f of x, isolate your something squared, and you got your x-intercepts. And this really wasn't a whole lot of steps. If I would write smaller, it wouldn't take up so much space. All right, so it's helpful when the equation's not factorable to save you from having to then use, find the vertex and then use completing the square anyway, right? Or the quadratic formula. But in this case, I wanted to kind of show you the steps through it. Right? So I completely forgot that I thought I had 2 examples. I had 1 example, and that was the equation of our equation in vertex form. So f of x equals negative x plus 4 squared plus 25 represents the same graph as f of x equals negative x squared minus 8x plus 9. Right? It just looks different, but it represents the same graph and the same values. If you plug in values for x, you would get the same values coming out for y from both graphs. Let's finish this graph off. So we took a little more time on this lesson, but I'm going to go quick through the other ones. I wanted to solve this by factoring because this was factorable. So let's find our x-intercepts one more time and see if we had the same answers. All right, so first of all, I notice that we have a greatest common factor, -1. So it would be a good idea if I factor out the -1. If I'm solving, I'm going to replace f of x with 0, right, because the value of y on the x-axis is 0. Now we can simply divide both sides by -1. And now we have 0 equals x squared plus 8x minus 9. So it does make sense to divide everything by -1, so then you don't have to deal with a -1 later on. Right? It makes things easier. It's easier if x squared is positive. So now we have our a is 1, our b is 8, and our c is -9. And if we were to multiply 8 times c, we get 1 times -9. So we know, for our factor by grouping, that we need to rewrite our b value as two numbers that multiply to give us -9, but add to give us 8. And what's that going to be? Well, it's going to be a +9 and a -1. Right? So -1 times 9 equals -9. -1 plus 9 equals 8. So we will work with the equation now where we've divided everything by by the -1, because when we're solving, we don't care about a anymore. We're just trying to find out the values of the x's on the inside. If we're rewriting, we care about a, right, because that a value gives us the direction and the width of our parabola. So let's do factor by grouping. So we have 0 equals x squared. Actually, let's put the 0 on the other side. Sometimes it's nicer to have it over there. So we have x squared plus 8x minus 9 equals 0. We replace that 8x with a -x, so x squared minus x plus 9x minus 9 equals 0. First to our group, second to our group. Factor out our greatest common factor, which is an x, and we're left with x minus 1 when we divide those by x. We can divide 9x and 9 by 9, and 9x divided by 9 is x. -9 divided by 9 is a -1. And now we can factor out the repeating, so x minus 1 is one factor, and the leftovers, after we factor out the repeating, are the second factor, so x plus 9. There we go. And our last step is just set them equal to 0. So x minus 1 equals 0. Add 1 to both sides. X is 1. X plus 9 is 0. Subtract 9 from both sides. X equals -9. I don't typically, necessarily write -9. I just remember I'm subtracting, right? So it's going to be the opposite. If it helps, you can always, put a -9 in here and a -9 here, and then you can see it's x equals -9. Right? That's fine if that would help you out. Right? So we have our x-intercepts, we have our vertex, we have our y-intercept, we have everything we need. Direction, you name it, we have it. All right? And I really don't take 30 minutes to graph each one of these, only if you solve everything two different ways. Oh, we didn't check. Let's check to see, did we get the same solutions as when I solved using vertex form? 1, 0, -9, 0. And we got 1, which would be 1, 0, and -9, which would be -9, 0. Yay! We solved it two different ways and got the same answers. All right, so let's do the last thing, which is graph. And once you have all the points, it's really super, super easy. So the vertex was x equals -4. Our axis of symmetry, I'm thinking in order here, our axis of symmetry was x equals -4. Remember that the parabola was concave down. I didn't put a spot for direction. And the vertex was -4, 25. And our y-intercept was 0, 9. Our x-intercepts, that looks like 0a. Our x-intercepts was positive 1, 0, and negative 9, 0. Right? All right, let me just make sure. Yes. I don't write it down wrong. All right, so 1, 0, and negative 9, 0. All right, so let's graph those. And so here I'm going to use that for my axis of symmetry. All right, so it's at negative 4. And, well, obviously, you can see that I don't have enough spaces on the y-axis to graph 25. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So let's let each one be worth 2. So that means negative 4 is going to be 2 this way. And you do your graph the exact same way as mine. So this represents this represents 2. And this would represent negative 2. And same thing on here. This would be 2, and this would be negative 2. Try to always keep the same scale on the x and y, unless it's just would be very, very difficult. Maybe the y or the vertex was 150, and then maybe you had to change something. All right, let's graph our points. So we have our point negative 4, 25. So remember, we're going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Right there, splitting that because each one is worth 2. Right? So we have the point 1, 0. Right? So you're not going to go one space over. You're going to go over. Actually, let me write in another color so that I'm not competing with all those blue 2s. So this would be 1 right in the middle, right? Because each box is worth 2. And then, and I'll even write that in there. So that was 1, 0. This point here was negative 4, 25. We have negative 9, 0. So this is 4, 6, 8. So right here would be negative 9, 0. And our y-intercept, which was 0, 9. So 2, 4, 6, 8. So right here is the point 0, 9. Now we can use symmetry. So if I have 2 this direction, I have a point 2 this direction. So that would be negative 6, right? Because each one, so this is negative 8, negative 8. If I'm 4 spaces over, and each one is worth 2, that'd be negative 8. Right, so negative 8, 9. And now we have all the points we need. So let's connect. And we know it's got to be facing concave down, so it's facing down. And our last point's right there. And that's it. We're done. Half hour later. Our domain, and the domain of every single quadratic function, is negative infinity to infinity. The range, you look to your vertex. It's concave down, so the ends, so even pointing which way they're going to go all the way to negative infinity. The high point because when you look at the vertex, make sure you take the y, because the range is y. So domain is x, range is y. The greatest y value the parabola reaches is 25, and we use a bracket because it does go through 25. That's the end of this podcast. Right? And so hope you've learned a whole lot about graphing in standard form. We'll see some more graphing in standard form in a review lesson a little later on. But first we'll look in the next podcasts, in the next lessons, we're going to look at graphing in vertex and intercept form. Bye for now.